Back for another day in the lights. So Wally, last time, Wally Rhines, I'm sure everybody knows him, Chairman, CEO of Mentor, a Siemens business.
President and CEO of Mentor, a Siemens business.
But a much larger business. Okay. However, last time we looked at the industry, and this goes back, I think, to last DAC, it looked like the entire industry was going to be boiled down to a handful of companies and everybody was swallowing up. Consolidation has slowed down considerably. Is this a pause or is it something that is a trend? You seem to have been following this for many years.
I have. So I am heavily influenced by data, and the data is not quite so overwhelming as the emotion associated with what's called semiconductor consolidation. Several factors. One is, even with the $100 billion a year of market value acquisitions that have occurred, with almost 70 acquisitions over 2015 and 2016, it's still a relatively small consolidation. The top 10 semiconductor companies now have a combined market share 2 points greater than they did before this big wave, and they're still about 2 points higher than they were 40 years ago. So not that overwhelming. Number two, the semiconductor revenue. It looks like they are a bigger percent of semiconductor revenue than is actually the case, because increasingly in recent years we've stopped measuring semiconductor revenue to the same degree of accuracy we used to. Why is that? Well, companies like Apple, Samsung, Huawei now make their own application processors. So when you look at the semiconductor data, the growth year to year, you see the semiconductor revenue from Taiwan Semiconductor and other foundries, but you don't see the other 50% of the revenue that occurs, for example, if Apple were to buy its application processors from Qualcomm, then it's recorded at twice the number that it's now recorded at today. When you add that all up, in a single year, that's been more than $10 billion of revenue subtracted out of the semiconductor TAM. So that's one more element. The third is that the actual combined market share of the 50 largest semiconductor companies has decreased over the past 10 years. That is, market share is not consolidating, it's actually decreasing. And why is that? It's because it always has. The semiconductor industry is an industry where you climb to the top based upon a specific capability, and you build a large market share, and then you become big enough and you grow at about the same rate as the overall industry. But all the new startups and new companies are entering based upon a new wave of growth, so they're growing much faster than the overall semiconductor industry, and over a period of time, they displace companies in the top 10 and become part of the top 10 infrastructure, and they too have to be innovative and nimble if they want to stay in the top 10, since 2/3 of all companies that have been in the top 10 are no longer in the top 10. And finally, one of the signs of maturity of the semiconductor industry that's always cited is that just like any mature industry, like steel or cars or whatever, the semiconductor industry has now plateaued and the growth rate is low, and it needs to consolidate for efficiency, just like all mature industries seem to do. And I would point out two things. So for one, it's not really consolidating. Number two, it's actually growing a lot more. And number three, people point out fabless startups. There are hardly any fabless startups anymore. Well, there were reported, anyway, 800 additional fabless startups in the last 2 years in China alone. And because of the China government stimulus, the estimates are that the Chinese semiconductor revenue will grow to $350 billion over the next 8 years, which is more than 100% of the semiconductor revenue of the world today. So a lot of factors say, yeah, don't take that consolidation too seriously. 80% of it was 6 mergers. And even though there were a lot of much smaller ones, almost all the dollars were in just 6.
Well, isn't part of what's going on that industry is getting set for the next waves of growth? So in the past, we've gone from PC to mobile, and the mobile processors are still a huge amount of the industry, but it's not growing at the same rate it was in the past. There's a lot of new things coming. That's going to drive a whole different wave of startups, a whole different wave of growth, and different ways of doing things. And what you're seeing now from these startups as well as from some of the consolidation is revamping of the industry from a top level down as well as what we're doing on the chip level from the bottom up, right?
And I would repeat, this happens about every 10 to 15 years in history, sometimes less, sometimes more. In my early days in the semiconductor industry, the success in the military aerospace was really what drove the largest growth. Then it was mainframes, then it was mini computers, then it was PCs, and it was laptops. In the last 10 to 15 years, the biggest part of our growth has been wireless. Communications as a segment has gone from 15 to 20% up to 35% now, equal or even greater than computer as a segment. And once again, like every other time, the winners sort of consolidated out, and so there are a lot fewer companies that are generating a large share of the wireless revenue. And so as a result, it's now a big semiconductor business. It can't grow in double digits anymore. And so we're waiting for the next wave. What's the big thing that will cause the next wave? We know it'll happen. It always does. We just don't know what it is. I was sort of encouraged by the presentations from, well, particularly Tyson Tuttle's this morning, because if you listen to Joe Costello earlier in the week, he pointed out that, hey, the information is everything. Those who own the data and the analytics and the ability to process the data make all the money. Tyson sort of put a little different spin on it today. He said, you know, making IoT devices is not all that bad if you wrap enough software around them and make them proprietary and differentiated. So I don't think it's over. The possibility of one of these IoT segments being the seed that grows the next wave, he was speculating it could be lighting. Whatever it is, we will have additional waves, and maybe this time it'll be many waves that add up to a big wave, all IoT or interconnect related, or maybe it'll be another big one like wireless.
What I think a lot of people found surprising of the last wave of consolidation was the size of the mergers. I mean, Mentor is part of this as well. What's different about that? How does that affect, you see it from the inside now, having been bought by Siemens. What's changed for the company? What are you seeing that's the driver?
So there are several different types. There are mergers that are driven by efficiencies, where you simply eliminate duplication, reduce costs, and if you do have overlap, you gain market share in segments, or you just bulk up. And that's actually more common than not. Of the mergers, 65 of the mergers that made up the last 2 years, the average synergies quoted, synergies are a euphemism for cost reduction, were 25% reduction in operating expense as a result of the mergers. So there's some more aggressive than others. Avago was clearly very aggressive in their projections of synergies, some less so, but the average was 25%. The interesting part is people thought, wow, that means they're going to cut R&D or R&D and G&A by 25%. So what happened to the R&D? The R&D in 2015 for the semiconductor industry grew. The R&D for 2016 for the semiconductor industry grew. It didn't take away the R&D, and if it did, new competitors would enter the market and take advantage of the fact that the establishment was not investing. Now, your question was with regard to Siemens. I would extend it to the SoftBank ARM, the Siemens Mentor. This is a totally different kind of acquisition. In both those cases, you read the press release, there is not a word about cost synergies or cost reduction, because there is no planned cost reduction. What you see in the Siemens press release is revenue synergies. So it is Siemens' belief that Mentor, by spending more on R&D and customer support, can grow its revenue faster than if we continue the way we were before. And that was a factor that the board had to consider. How fast could we grow? Could we maintain and grow our market share as a standalone company? Or what if we had someone with very deep pockets, with a slower growth rate than we had, that was looking for new areas to invest in, new areas to expand in? And that's what Siemens presented to us. We want you to invest more, and as a result, we want you to grow faster. And of course, we responded, you know, the areas we will invest in will be the areas where we have number one market positions or have the likelihood of getting a number one market position. So that means for Mentor, which is really different from other EDA companies, we focus it in things like the Caliber family of 40 products, like design for tests, high-level synthesis, emulation, and things like that, plus some where we are gaining market share very rapidly and doubling revenue, like SPICE simulation, for example. And then on the system side, in areas like cabling and wire harness and specific areas of automotive embedded software. And so for us, it's a totally different kind of thing than the typical merger and acquisition you read about. Those were available to us as well. Not clear they would have gotten through the antitrust process, but they would have been very destructive for employees. They probably could have been equally beneficial, maybe even more so for shareholders, but for the long term, our customers are the big winners here, and that allows us to serve them better, develop more products, do a better job, offer better careers for our employees.
Well, I think the big question for a lot of the EDA industry, though, is in the past you would create a startup and you would either get bought or you would go public and try and grow into a Mentor, Synopsys, and Cadence. Now a Mentor becomes part of Siemens, and the question is, what does EDA look like going forward? What's the future for a lot of the companies, and what's the future for the technology itself? Is it now part of a design for a chip? Is it part of design for a system? How does it change?
So lots of questions built in there. So first of all, as a student of EDA history, I frequently highlight the fact that there have always been three big companies: Computer Vision, Calma, Applicon, Daisy, Mentor, Valid, Mentor, Cadence, Synopsys. And they've gone for long, long periods before anybody was displaced or anything changed. And Mentor, Cadence, and Synopsys have had a combined market share of 75% plus or minus 8% for the last more than 20 years. So now we've disrupted that stability. What effect will that have on the future? Well, first of all, you look at Mentor's history. Where did we grow and where were we limited? In design methodology and tools, we grew at about 2 times the market rate. So why wasn't our overall revenue growing much faster than the market as well? And the answer is that even though we started the IP business, we eventually dropped out of it. So in 1994, 95, we did 29 acquisitions of IP companies. We built the largest market share. Everything's going great. And then Synopsys discovered what was going on and got aggressive. And we simply didn't have the money to counterbid. They had deeper pockets, so every new startup, every new technology, we go bid for the leader, IP, and we would lose. And Mentor, I guess because of me, had a strategy that says, look, you're either number one or you're going to be number one, or don't clutter the world with yet another competitor. The world doesn't need 3 suppliers of everything or more. So we de-emphasized. Now you look going forward. We've got very deep pockets now. We have a parent that does $90 billion a year of revenue with very large positive cash flow, a desire to grow faster, and a belief that virtual design of electronics and of systems is where the biggest growth will occur. As you heard from Chuck Rhines' staff yesterday, digitalization, the ability to virtually verify, the ability to go from concept through design, development, manufacturing, and support, and do this all on computer. And a company that has quite a strong foundation in data management, in mechanical CAD, in device modeling, computational fluid dynamics, and so on. Now, a division that, in fact, has a high level of competence in electronic design, both system and IC. What happens going forward? Well, one thing is the money is there for us to compete acquisition-wise. The resources are there to grow into new areas that we have not been investing as fast as we could. And then number three, and I suspect you'll have more questions on this, it also provides the first company that has true electronic capability to start penetrating this interface between system design and IC design. And that is a big opportunity I've talked about at almost every meeting I've been at before, because in IC design, we're pretty well automated, pretty well penetrated through the entire flow. In system design, the world is in the Stone Age, so a big growth opportunity exists if you can design and verify a car, plane, or train virtually instead of building prototypes and testing.
We've been discussing this for probably about the past decade, though.
At least, yes.
Why is it going to go forward now when it did it in the past?
So, first of all, some, I guess, opinions I have about things. There have been people promoting the theory for more than a decade, 20 years, and they've come to Mentor in the past and said, you know, we think all this mechanical CAD has to come together with electrical, and you're going to have one great terminal, and every engineer is going to use the same terminal so they can get access to all the data. And I have been one of the greatest critics of this, and I still am. I don't believe electrical design engineers want to sit at a terminal that is general purpose enough that you can do mechanical CAD and electrical and so on. What they do need is access to pieces of information in the other domains. Why are startups successful when they're competing against big companies? My conclusion is a new problem comes along, companies try to develop a solution. The big companies have the software development in one group, the hardware development elsewhere, IC design elsewhere, and they're all working and they never get an optimum system solution. The startup, the software developer, is the same person as the hardware developer, who is the same person as the marketeer, the salesman, and so on, and they look at the whole problem and put it together. What has to happen for system design to automate the same way IC design has done? They have to get tools that can allow the electrical designer to get access to enough of the embedded software and the mechanical design that you can develop solutions that are optimum. Today, Mentor has the leading market share in developing and designing, or tools to develop and design, wire harnesses for cars, planes, and trains. You say, now wait a minute, let's think about this. First of all, how difficult can this be? You know, hey, it's a wire harness. You know, this is not an integrated circuit. And the answer is, it can be very difficult. First of all, it's a three-dimensional wiring problem, which your IC is becoming, but is not really yet. Number two, there are thousands of constraints that have been built up over the years. One car company will say no more than 5 wires in a bundle and a wet zone in the car, and some other car company has a different set of rules. Those constraints are just like the constraints you have that are built into your router and into your verification tools. Now you get the problem of, wow, we've got 150 ECUs, we've got 100 million lines of software code, no human being can develop and verify the wiring, so now you have to go to automated wiring. Well, how do you know that the wire bundle will fit through the hole in the door frame? How do you know that the wire is long enough to go up through the roof of the car and back down to the other side? The answer is that's in the mechanical database. How do you get access to that? With great difficulty. But over the let's see, we introduced the product in 1992, so over the 25 years that Minter's been doing this, we found ways to get that data. But I can tell you, it hasn't been easy. The suppliers of the mechanical, or the owners of the mechanical data, are somewhat reluctant to give access to that data. So over the years, we've managed to get by. But when you have a partner that now gives you total access, it now motivates your other suppliers to do the same so that you can provide an efficient solution. Now all of a sudden you have a car wiring system that can take into account all sorts of aspects of the mechanical design and optimize with the electrical design and produce a lower cost, shorter wire length, more efficient, more manufacturable system, and you can do all sorts of things you couldn't do before.
Let's bring this down a few billion microns. One of the things that we've seen going on these days is a push toward much more heterogeneous systems. That includes more different kinds of components, accelerators on a single chip. It also includes more chips in a package and more components on a board. What does this mean for designers?
This is what's really great about EDA right now, because if you distinguish between what's different about a system designer and an IC designer, traditionally it has been one designs components, the other integrates disparate technologies into system solutions. System suppliers typically run higher margins than component suppliers. In SoCs, people who do more complex integration run higher margins on their ICs than people who sell commodity components like memory components. And we are moving into the age of design automation for systems, which means we can add more value. But it requires new expertise. So if you look at an IoT module like Tyson talked about today, now all of a sudden we have to worry about the fact that you have Zigbee, Bluetooth, RF, digital, analog, MEMS, photonics, all of this working together on this little IoT module. Well, how many people have experience in simulating analog and digital together, much less analog, digital, RF, MEMS, photonics? This is a system design problem. And the new innovative designers who take advantage of this and who develop that system level verification and design capability are going to be well rewarded, as are their companies, because it's not easy. So you hear EDA companies, particularly Mentor and Cadence, talking about our packaging technology, multi-chip technology, support of info and other new standards. You hear us talking about our integrated simulation where we can do verification of RF with analog, with digital. In Mentor's case, you hear us talking about Tanner EDA because they are the father of being able to integrate relatively low complexity mixed technologies. More than half of all MEMS designs, more than half the fab loadings at XFAB come out of designs done by Tanner EDA, and a large share of those are done by people who are not expert IC designers. They're system people working in big companies and small who start out with a relatively low complexity, and they need to grow upward to add mixed technologies, add digital, grow the capability. It's a whole new wave of EDA. It's a whole new wave of opportunity to develop expertise that will be well rewarded and that designers need to get onto, need to spend time, because big digital has gotten very, very big, but it's not going to grow at anywhere near the rate that startups and new designs are going to grow in mixed technologies.
So what becomes the next challenge? Is it technology? Is it business? Is it ecosystems? Where do you see the problems?
Well, there are always problems in all dimensions. So every time we get a new node, we get a new set of physics problems, we get a new set of complexity problems, and a lot of the tools break, and we have to develop new generations. But let me separate the evolutionary from the revolutionary. So traditionally, EDA grows not by evolution, but by revolution. If you go back and look at the segments of EDA, the mature ones, even though they encounter new problems with every generation, the revenue doesn't grow much. Event-driven simulation has grown 1 to 2% per year over the last 10 or 15 years. Place and route has grown about 2% over the last 10 years. PCB design tools have grown about 1%, 1.5% for the last 25 years. So just each of those technologies has had to dramatically improve its capability to manage the complexity that's occurred as electronics increase, but you don't get rewarded for it very much. People expect you to expect to buy from you the new set of tools for basically the same number of total dollars plus a little each year. And yet, I know in our event-driven simulation, we increase the number of lines of code by about an order of magnitude per decade. Where does the growth occur? The growth occurs when a new problem comes along for which there are no tools. 1999, optical proximity correction. EDA industry, 0 revenue. Today, optical proximity correction is one of Mentor's largest businesses. We have in excess of $100 million a year of revenue. The industry is approaching $200 million of revenue, and it's growing very, very rapidly. Didn't exist 15 years ago. It now is not only a big part of EDA, it's a fast-growing part. Well, the same is true of these other new technologies that come in. Someday photonics will be one of those. It's not today. But in the last decade, analog mixed signal in various forms has grown. We've had substantial growth in other new technologies like high-level simulation and synthesis has grown from roughly 0 in the 1990s to $150 million market today. Our high-level synthesis and power optimization tools that we have with the Calypto family doubled its revenue last year. The new technologies that are solving the new problems are where the growth occurs, and the granddaddy of them all is system design, the ability to apply the fundamentals of IC design automation to designing systems on a chip and systems that are bigger systems and integrating that with embedded software where the verification problem has increased dramatically and where the revenue growth for EDA companies is growing substantially as it has for Mentor.
Is there a distinction here on growth between where there are no tools and vertical markets? They're not necessarily the same, right? So you can go into automotive with the same tools even though they have no history of the electronic components that are there.
Absolutely.
What you're talking about is solving a completely different problem.
Yes, so I'm talking different problem, different technology typically. But in fact, for years, the investment analysts used to question us, say, well, what's your largest segment? Do you sell more to the computer segment, communications, and so on? And the answer for EDA has traditionally been, the same simulator is used by everybody. The same place and route is used by everyone, and so on. Well, what has evolved in very slowly were special tools for special vertical domains. So when you hear Mentor talk about automotive being almost 20% of our revenue, there are two pieces to that. One piece is printed circuit board design. It's not greatly different than the same PCB tools we sell to everybody else. But there's another part of it that's very big and growing that is very specific to automotive, and that is a set of embedded software, wiring tools, computational fluid dynamics tools that are in fact developed specifically for automotive design that are not used in the other areas. And that has been a big source of growth for the company. And over time, I suspect there will be others that get interested in those things. But up to this point, for tools, actually EDA tools for automotive design, there's been virtually no competition yet from the EDA industry. I think that'll probably change.
Looking at vertical markets, and I'm not sure this is vertical, I'm wondering your view of the IoT. Is the IoT a separate market, or is it actually an overlay over existing markets and sort of a fundamental way of connecting them together? So a smart refrigerator is still a refrigerator. A smart vacuum cleaner that can do robotics around your house is still a vacuum cleaner.
Yeah, well, as Joe and Tyson highlighted, Just making a product automated or connecting it is not, in fact, very powerful for generating differentiated value in the Internet of Things. Joe showed an example I thought was good with the Nest thermostat controller, which, as long as all it did was let you change the settings on your thermostat through your iPhone, it was not very value added. Now, the things Tyson talked about today and the examples Joe gave put intelligence and data analytics into that IoT solution, and suddenly it becomes something much more different. It's an engineered solution that has semiconductor components, it has electronics, it has a lot of embedded software, but in fact, it takes the information that is available to it through connectivity and it performs intelligent tasks so that instead of just turning things on and off, it anticipates the need. Tyson talked about his sprinkler system getting the weather forecast and the humidity and everything else and integrating that into whether the sprinklers needed to run, things like that, and much more complex ones. Joe talked about using the lighting system to have sensors that can control space utilization and locate lost equipment and do all sorts of other things. And I think that's really what makes IoT different than simply developing smart sensors and actuators and integrating them and making them connectable through communications. It's the intelligence and then what you do with the data. I would, however, caution the big money is with the information owners, and the information owners who take your data and sell it back to you with intelligence applied are going to make a lot of money over time.
Is that a big company game, or is it something that others can get involved in? How do you see that unfolding?
Oh, it's happening in startups as well as big companies. I think the difference is, how does a semiconductor company or some kind of system company that does chips, how do you capture more of that information value? You hold a very important key to the development of the sensor collecting mechanism and the storage of that data and even the processing of that data, and in many cases the intelligent algorithms that go with it. Can you form a partnership with the company that does the deployment or works with the end user in order to form something that has more value added than simply selling components? Some of the examples shown in the presentation, of course, one of the big ones is how do you do maintenance of engines for aircraft? It used to be that you had scheduled maintenance and preventive maintenance, and the engine manufacturer sold the airplane company a maintenance contract, or sold the airline a maintenance contract. Now you have continuous monitoring of the equipment. You look for signs that there may be problems, and you have a unique value because you've collected billions and billions of terabytes of data, and so you know things that the individual airlines don't know about their own engines, about when they're showing those signs. How does the person who builds the sensors and actuators get in that revenue stream? Can you form a partnership up front where you capture your value? There are precious few examples so far, but I'm betting that there will be more and more innovative people who find a way to dip their hand into that money stream.
One piece which overlaps across a lot of this is security. It's crossing over into the critical safety critical market. It's crossing over into a lot of other things. It's a big concern of a lot of people. Can the tools that exist today be used for security, and if so, how?
So, big topic for EDA, big topic for the semiconductor industry. And as some of you know, Minter's been developing products in this area for quite some time, because while it hasn't become critical yet, we believe that ultimately you'll need to have trustworthy silicon as part of the total solution, because chips will be subject to Trojans, and companies will get more and more concerned about what gets into their chips and how they're protected. And you already have sensitivity at a very minimal level with ARM Trust Zone and things like that, and then a lot of proprietary things internally. Over time, it will become one more big part of IC design, one more big part of verification. The tools will be available to help you, but as Art was highlighting yesterday, this is a dynamic. Unlike a physics problem you solve and it stays solved, the security is one where the people working to break the security are just as smart as the people working to improve the security, and so it'll keep us all employed for a long time. And there are already products available to you that let you design a chip so that it can be produced in a foreign fab, and yet the actual algorithms are not open or available until such time as you finish the assembly and you program in the security codes that go with it. There are other aspects of the design, like how do you screen IP that you get, and the answer is with great difficulty. But there are many, many things you can do to camouflage your design, to make it very, very difficult for the bad guys. And as they get better and better, we'll come up with more and more ways to protect against them.
The challenge has been getting people to pay for it, and it's a payment not only in terms of money, but also in terms of design time, power, and also performance. And particularly if you want good security, it's probably active as opposed to passive. Is that going to change? Do we need a massive breach? But it seems like we keep having massive breaches.
Yeah, well, you saw in one of my keynotes a few years ago that I was speculating that if we could just have a big disaster, someone loses a lot of money or gets killed or something, then all of a sudden the semiconductor chip customers would come to their suppliers and ask them to sign a liability statement saying that your chips contain no Trojans or any other bad things, and then all of a sudden this would be elevated, and then every designer would become aware of it. It hasn't happened, as you said, but I am interested that a little side advertisement for the Semiconductor Research Corporation, SRC, which I've been on the board of for 15 years, we actually have now a special thrust in automotive security that has the who's who list signing up for work there. And remember, this is the Semiconductor Research Corporation. This is not the Automotive Research Corporation. And these are automotive OEMs, tier ones, and semiconductor companies that care greatly about the security of the chips that are ending up in cars, enough that they're paying $300,000 a year to be members of this research consortium that will fund university research in this area.
We used to have massive organizations that would do that kind of research. IBM, Bell Labs, DARPA was doing a lot more research than they are currently, and also a whole bunch of military agencies. Where are we now? A lot of that seems to have fallen off, and what impact is that going to have on us?
So interesting trend. So SRC actually had its budgets declining for quite some time as these big mergers occurred, and so 2 members would become 1 member, and we had a max rate for dues, so it would cut out revenue, and it was in decline. And Ken Hansen took over, came out of Freescale, and really dug into the problem, and then started a bunch of thrusts that had real relevance to the investor community, and major new companies have come in and joined, like ARM, like a whole variety, TSMC and others. And all of a sudden, consortia research of university research in semiconductors has turned around, at least for the SRC funded part, and I would guess actually in total. So I think we're on an uptrend. We've got enough new problems that people are excited about that it's not so difficult to get them to kick in fairly large sums of money for consortia research, in addition to what they're spending themselves.
Well, this is a global race right now, isn't it? And the U.S. is fairly far behind.
Well, the scary part, or I guess good part if you're Chinese, is that China is investing about $120 billion over these next few years, more than half of which originally went into manufacturing. So if you build DRAMs or flash memory or something, get ready for a big increase in worldwide capacity. But now the emphasis has switched to design, fabless companies, and other areas of innovation. with the goal of China becoming self-sufficient in semiconductors over a period of time. And so investment is enormous. Semiconductor demand will grow, but demand for design tools, design infrastructure is being dramatically affected by what is the single largest growth in investment in history. And I think we're going to feel the effects of that. The effects will be very good, and I'm hopeful that they will remain good, that China won't become so big that it dominates the industry. I take you back to when we used to believe Japan would do all the semiconductor manufacturing in the world. In the 1980s, when I was at TI, we were depressed that everything seemed to be going to Japan for manufacturing, and yet that turned out to be just one wave. There were other waves to follow, and I'm sure there'll be more in the future.
One other sort of step change in there is that the introduction of the cloud and a lot of things that could be done on the cloud these days that could not be done in the past. So instead of having to own all of your own equipment and all of your own servers, you can now license this on a piecemeal basis as needed. How does that affect the dynamics here?
So you're talking design or everything?
It's heavily on design. Let's focus in on design because I think that's more relevant to this audience, but it certainly has implications for a lot of things.
Yeah, so all of the EDA companies, at least 5 years ago, made deals with AWS and other server farm providers or capacity providers so that if customers wanted to take advantage of the use of a farm, they could. And I was on a panel with Art, I don't know, 3 years ago, I guess, and Art went through a big, long description of all the work they'd gone to make this possible, and he ended it by saying, and now we have exactly 0 customers using it. Well, the reasons were many. One reason was security. At that time, people didn't really want their design information to go outside their firewall. It amazed me because they had no problem with their bank accounts and stockbroker accounts and so on, but they didn't want their design information to get out of the firewall. Nowadays, I think people say, yeah, AWS is pretty darn sophisticated in terms of security, so maybe it's not such a big worry, but still, semiconductor companies don't like their information getting outside. But actually, the bigger impediment was initially we had lots and lots of people come to us and say, okay, I want to host it externally, and this looks like the future to me. So what can you do? We tell them what we can do, and then we start talking price. And they say, yeah, I want to buy 1 day of caliber verification. How much will that cost? And we would say, no, wait a minute. If you rent a car for a day, do you pay the same rate as if you rent a car for a week? And what if you rent a car for a year? What's that rate? We do the same thing. And they suddenly concluded, wait a minute, buying a minute of simulation is going to be really expensive compared to buying a year of simulation and dividing it up. I'm not going to save a lot of money doing this. And all of a sudden, the enthusiasm, which was going like that, went like that. And they decided, our server system is pretty good and it's pretty economic. And so the whole thing for design automation sort of died out. I think it'll come back. I think there will be, we'll settle out the pricing models and other things with time. And ultimately, the algorithms more and more will take advantage of the enormous capacity available because not everyone can afford 60,000 servers in their company, and there will be a trade-off, and it will emerge. But it's been very slow in design automation compared to a lot of other industries.
Thank you, Wally.
You're welcome, Ed. Thank you.